Hello and welcome to another day of Living Environment. I am Miss Parsons. Let's go ahead and get started with Unit 1, Scientific Inquiry, Day 3. And today's aim is what is the importance of the scientific inquiry method? And that is very similar to our aim from yesterday, and that is because this method is extremely important. And why is it important? Well, that is because this is the method by which science is conducted. So not just any research or experimentation is scientific. We want to learn what makes experiments valid. And the validity of an experiment is based upon the quality of its data, and if it has gone through a peer review process that has the consensus of scientists like we talked about in the last video. And what that means is that the experiment is able to be replicated, that it has a representative sample of data, meaning that the experiment, for example, if you're trying to determine if a plant could grow with Diet Coke, and I didn't set up any detailed experimental procedures, and instead I just started throwing Diet Coke on a plant that was already in my office, and that plant doesn't die, and I say, congratulations, plants can grow with Diet Coke. That was not a very valid experiment because I didn't use the scientific inquiry method. And we're going to talk more about that as we dive into today's lesson. So let's start with the do now. Which statement best describes a hypothesis? A hypothesis is a process of making careful observations. The conclusion drawn from the results of an experiment is part of a hypothesis. A hypothesis serves as a basis for determining what data to collect when designing an experiment. Or the facts collected from an experiment are written in the form of a hypothesis. I feel like Dora the Explorer waiting for you guys to answer, but the answer is obviously C, right? So a hypothesis is a testable guess. Ooh, testable guess, you can barely read that. That is used as the foundation of an experiment. An experiment. And now that takes us to part A, the vocabulary review. So what is the dependent variable? You guys hopefully recall from yesterday's video that the dependent variable is the variable that is being measured. The dependent variable is the one that is being affected by the experiment. So let's go back to my favorite example. Can we grow plants with Diet Coke? The dependent variable in that case is whether the plant grew or not. And you may define it in your experiment as the number of inches that the plant grew over a week is the dependent variable. What is the independent variable? The independent variable is the variable that is being controlled or manipulated by the experimenter. So that is the cause, right? So we've got cause and effect. And please make sure you're following along and filling in on your notes as well. The experimental group in an experiment, going back to that same example, we're using the scientific inquiry method now. We want to make a valid experiment instead of just tossing Diet Coke in the plant in my office. So we'll have two groups. We'll have the group that had plants watered with Diet Coke and the group that had plants watered with water, because that is typically what you use to grow plants. In that case, the experimental group is the group that's being watered with Diet Coke. It's the group that's receiving the experimental condition that is being tested, the experimental version of the independent variable. And the control group is the group that is not receiving the experimental condition of the independent variable. In this case, the group that is getting the plants watered with water. So now let's take a look at some examples. Here we go. So Let's take a look at Homer. Part B, scientific method practice. Homer notices that his shower is covered in a strange green slime. His friend Barney tells him that coconut juice will get rid of the green slime. Homer decides to check this out by spraying half of the shower with coconut juice. He sprays the other half of the shower with water. After 3 days of treatment, there is no change in the appearance of the green slime on either side of the shower. So what was the initial observation Homer made? His shower is covered in green slime. Green, here we'll use green, slime, all over his shower. So his hypothesis, based upon some prior experience, his friend Barney tells him, coconut juice will take care of this green slime problem. So his control group is the half of the shower that he is spraying with water, right? Because that is usually the liquid that is sprayed in a shower. So the control group is half that is being cleaned with water. The independent variable, the manipulated variable, is the coconut juice, or rather what is being used to clean the shower. Coconut juice / cleaning fluid, right? Because the two conditions in this case are water, the control condition, and coconut juice, the experimental condition. So what is the dependent responding variable? The amount of slime. What should Homer's conclusion be? Well, based upon this limited amount of data, right, he just has the one trial of this experiment, I would say Barney got a different result than he did, so perhaps go back and perform your experiment again. But based upon this data, we can conclude coconut juice did not help. Otherwise, the results are null, is a scientific word that you can describe that. Basically, there was no new information gained because a previous study conducted by Barney was that coconut juice could help. Homer says otherwise. So how can this experiment be improved? There are many answers to this question, but the primary one is more trials to determine if Barney was really onto something or what. So now let's go on and see another example. There we go. Okay. So Krusty was told that a certain itching powder was the newest, best thing on the market. It even claims to cause 50% longer lasting itches. Interested in this product, because Krusty the Clown is a clown, of course, so he wants to prank people. Interested in this product, he buys the itching powder and compares it to his usual product. One test subject A is sprinkled with the original itching powder, and another test subject B was sprinkled with the experimental itching powder. Subject A reported having itches for 30 minutes, and subject B reported to have itches for 45 minutes. So what is his hypothesis? His hypothesis is that this new itching powder is going to make people very itchy. This new itching powder is the best. The control group is group or subject A, sprinkled with the original itching powder. Original itching powder. The independent manipulated variable is the itching powder. And the dependent or responding variable, the effect from that cause of having itching powder applied onto you, is how long being itchy. Explain whether the data supports the advertisement's claim about its product. So now let's take a look at the data. Krusty was told that the certain itching powder was the newest best thing on the market and claims to have 50% longer lasting itches. So based on his study, He has one test subject A sprinkled with the original itching powder, and they are itchy for 30 minutes. And another subject B is itchy for 45 minutes. So we have A and B here. And those of you that are math whizzes are probably already ahead. But if subject A was itchy for 30 minutes and subject B was itchy for 45 minutes, and the claim is that the new product causes 50% longer lasting itches, it was supported because 15 minutes is half of 30. And you can see that 45 minutes has an extra 15 minutes, an extra 15 minutes of itchiness. So yeah, Krusty's one experimental trial seems to have determined that, yeah, this itching powder is a pretty good product. How can this experiment be improved? Well, we want a larger sample size. What do I mean by that? So a larger sample size means Krusty is going to try this on many people. So test powder on more participants. All right, very good. Now our last example, and then don't forget, after we complete this example, you're gonna go and complete today's exit ticket, the Unit 1, Day 3 exit ticket, and submit that for accuracy. So, Smithers thinks that a special juice will increase the productivity of workers. He creates 2 groups of 50 workers each. So we've already got here, we're decoding our experiment. 2 groups of 50 workers each. His hypothesis is special juice will make the workers more productive. Increase productivity. And forgive me, guys, I'm trying to make the things that I'm writing on the screen legible, but they are pretty illegible. So we're working on it. So he creates 2 groups of 50 workers each and assigns each group the same task. In this case, they're supposed to staple a set of papers. Group A is given the special juice to drink while they work, and Group B is not given the special juice. So because Group B is not given the special juice, they are our control group, right? They did not receive the experimental variable. And what is the independent or manipulated variable? It is the special juice. So what did the workers drink while they were working? Did they have the special juice, like Group A, or did they not have the special juice? The dependent or responding variable is their productivity, in this case measured by the number of papers they stapled. What should Smithers' conclusion be? So it says here, Group A was given the special juice to drink while they were at work. Group B is not given the special juice. After an hour, Smithers counts how many stacks of paper each group has made. Group A made 1,587 stacks, and Group B made 2,113 stacks. Well, his conclusion, based upon this data, is that the special juice does not work, right? This is pretty special juice is not so special. Now, how could this experiment be improved? Well, Smithers could test different tasks, right? So this could have several answers. Smithers could test the experiment with different tasks, have them do other things besides just staple stacks of paper, right? I assume that's not their entire job, but just stapling paper. They could perform other tasks. He could increase the sample size, so he could test this on more people than just 50 workers. He could improve the experiment by doing it on the same group of people over a longer period of time, right? So he could increase sample size, more trials, modify testing, so the method of testing, and those types of things are part of this scientific inquiry process, right? So now that you have been given a smattering of some experimental setups, tomorrow we're going to talk more about what exactly makes a quality experiment, what makes a good experiment, and what are the components of a quality experiment. I hope you enjoyed this video and it made sense to you. Please come to class prepared with questions and prepared with comments, concerns, things that you understood, things that worked well for you, things that didn't, as we endeavor into this new year of online learning. Please don't forget to like this video, subscribe to my channel, engage with it, go ahead and comment, hit that little bell for notifications so you get notified every time a new video gets posted, and don't forget to submit your exit ticket and your notes on Google Classroom. I will see you all on Zoom tomorrow to discuss this topic. Have a fantastic day. Bye.